About the speed, you have to know that the speed is the the magnitude of the velocity. The speed doesn't depend on the direction, equal the distance traveled divided by the time. But the velocity depends on the direction. For this reason, the velocity equal the displacement divided by the time. And we know that the distance doesn't depend on the direction, but the displacement depends on the direction. It's a vector quantity. So the average speed equal the total distance d divided by the time t, time elapsed. It means we have the time between the initial point and the final point. And the displacement, the average velocity, I speak about the displacement divided by the time. Displacement equal, okay, now if I talk in two dimensions, equal r final minus r initial. It's delta r, okay? It's delta r divided by the time equal delta t. You can say here is delta t between them. You know this quantity if you want to write in details. R final, okay, you know the final formula of the displacement equal delta x I minus or plus delta y j. We calculated this formula in the last video. Divided by delta t equal delta x over delta t I plus delta y over delta t j. Okay, it's just a formula. Now I want to calculate the velocity at a point. Okay, the average velocity, I mean I calculate in general the velocity between 2 points. For example, in the last one here, when I talk about the average velocity, it means I want to move from the point A to the point B. Here, the object moves like this. Here we have, for example, V1. Here we have V2, etc. Here you have Vn. And we arrive here with VB. So we don't have a fixed values of V. For this, we can calculate the average speed and velocity. But when we talk about the instantaneous velocity, I mean I have to calculate the velocity at one point. So here I am going to calculate the velocity v at a special point, at the point A, at the point B, at any point. V in general, okay, V equal, we can say this is in one dimension. We can speak in general in one dimension. V equal dr divided by dt. Okay, it's important. This is the general equation of the instantaneous velocity or a velocity at any point. And if I want to calculate, for example, I have a motion of the object between this point and this point. I want to calculate at a special point, at this point. It's the point A. So I want to calculate VA equal delta R A divided by delta T equal D divided by dt. RA, we know that equal XA plus YA. We can erase this one. Okay, equal dxa over delta t plus dy y component over delta t. And you know, in general, v equal vx plus vy. Okay, we can compare this one with this one. So Vx equal dx Vx of A. Vx in general equal Vx of A. Okay, equal d over dt, and Vy of the at the point A equal dya over delta t. Let's talk more about this because it's important. When we talk about the velocity, it's very, very important. I give an example. V must be directed, okay. For example, I have at the we have x-axis. We can say here we have x-axis, y-axis, and we have an object goes with this trajectory. I want to calculate the velocity of this object at this point. We can say a point A. V is directed from the point and tangent to the trajectory. Always tangent. At this point is tangent. At this point is tangent. So this is VA. This is the center. Okay, VA equal D delta RA divided by delta T, as we said, equal delta XA over delta T plus D, okay, I don't want to repeat, delta YA over delta T equal Vx plus Vy. So Vx and Vy equal these values. Vx is the x component vector of VA. Vy is the y component vector of VA. I want to precise the direction of Vx and Vy on the figure. It's very important. At the point A, this is the point A, to draw the components of VA, what we do, x and y at the point A. We can do x and y at this point. So here we have the x component of VA and y component of VA, because we have to do the projection on the x-axis and on the y-axis. So here we have VAX or VX, and here we can say VAX. I am talking about A. And here we have VAY. And the angle, the direction is the angle between the x-axis and the vector VA. So as magnitude, VA magnitude equal root square VAX square plus VAY square. This is the magnitude, remember. And the direction of the vector VA equal 10 minus 1 V the y component over the x component. So we calculated VAX and VAY from XA and YA from the position vector of A. Can we draw the position vector? Yes. The position vector from the origin to the point. We said that always this is the position vector from the origin to the point. We can do the same for the point C, from the point D. Always, you know how you can calculate the direction, the magnitude of any velocity. It's like this. The most important point that the velocity is always tangent on the trajectory. Thank you.